Welcome back. In this video, we will configure gridmo standard template variables ready to use our PSS E model of Sunny Solar Farm. Before we begin, I recommend you have the documentation of your generator model open and either a screenshot of the PSS E model or the model itself open in PSS E, as we will need to reference the model itself quite frequently. Firstly, we will add the model files to the Gridmo Engine's inputs folder. The inputs folder is where we place all source models or data files we want to run with Gridmo. Inside this inputs folder, let's make a new folder called SSF, short for Sunny Solar Farm. Inside that folder, let's make a folder called V1. This is going to be the first version of our model. Inside V1, we want to create a folder for each power system software we are using to simulate Sunny Solar Farm. In our case, let's just create a PSS E folder first. Inside this folder, we want to copy the following PSS E files. 1. The case file with the extension .sav. This file has all the definitions for our SMIB model, such as transformers, lines, generators, etc. 2. The dynamic data record file with extension .dyr. This file has all the settings for our dynamic models, such as controller gains, etc. 3. The slider file with extension .sld. This is the single line diagram of our SMIB model. And 4, if we have any, library files with extension .dll. These additional libraries tell PSS E how to simulate OEM-specific models which are not built into the software. Importantly, all DLLs in this directory will be loaded by Gridmo, so make sure to only include DLLs compatible with the PSS E version you want in this folder. For example, don't put PSS E version 35 compatible DLLs in this folder if you are running PSS E version 34, etc. Now that we have all the files created, we are ready to get started. Let's switch to the Gridmo web app and click the Global Variables button and then select PSS E at the top. The first item we need to set is the relative file path to the PSS E case file. By relative, we mean this file path starts from your Gridmo Engine input folder. So in our case, that'll be ssf/v1/PSSE/ssf.sav. Note, your project doesn't have to use the same file names as Sunny Solar Farm. Next up is the dynamic data record file, which we copied into the inputs folder. It's in the same folder as the case file, the .sav, and it's called ssf.dyr. We can copy from the PSS E case file variable above and just change the file extension to dyr to save some time. Next up is the DLL folder path. For Sunny Solar Farm, we don't actually have any external libraries required, but it's very likely that you will. In this case, we want to point Gridmo to the folder where our .sav and .dyr is, ssf/v1/PSSE. A reminder that every DLL in that folder will get loaded, so only put the ones you need in there for your version of PSS E. Next up is letting Gridmo know what the POC bus is. POC is short for point of connection, but there are many similar terms throughout the world for the same thing, such as PCC, point of common coupling, or POI, point of interconnection. It's the final bus of our generating system, Sunny Solar Farm, in the SMIB model. Looking at the model, we can see the Thevenin equivalent impedance is the branch between bus 400 and bus 500. That means the end of our generating system is bus 400, and therefore our point of connection is bus 400. Now, we just said the Thevenin equivalent impedance was the line from bus 400 to bus 500. This variable is setting that value. In Gridmo, we use number, arrow, number, hash, ID, shorthand to define a line. As we are doing generator studies in Gridmo, we want all line definitions to be facing away from our generator. So we want to go 400 greater than 500 #1 for ID 1. As traveling from bus 400 towards bus 500 is heading away from the generator. This means we'll get the correct sign on active power, reactive power, etc. The values of the next global variables look a bit different to the other ones we've set so far. These variables have Gridmo commands in them. Commands in Gridmo are made up of a keyword, followed by a comma, then a series of arguments with argument equals value, which themselves are comma separated. The commands and their arguments are designed specifically for you to be able to read them and quickly identify what is going on. Our comprehensive online documentation is a great source for building or constructing these commands. The first two variables with gridmo commands, which together set the SMIB model system strength and point of connection voltage using the Thevenin ideal source, require only one change. That change is the definition of 999-1. In our sunny solar farm model, the PSS E swing bus, where the Thevenin ideal source connects to, is bus 500. So we need to change the 999-1 to 500-1, where the #1 is to tell gridmo to use the generator with ID 1. The next two variables use the gridmo set command to turn on and off a generator. Sunny Solar Farm's aggregate inverter is located on bus 100 with ID 1, so we need to change the 91003 S1 reference in both of them to 100-1. The next variable sets the plant targets for a PSS E static simulation. We can see the gridmo argument at line is being used, which tells gridmo to regulate it at a remote branch. Again, we need to change the 91003-S1 reference. Note, if our generating system actually had multiple aggregated generators, which is a bit more common for wind farms, we would have multiple gen arguments here, such as gen equals 100-1, gen equals 200-1, etc. Now we're at the final variable used in the PSS E static study definition. We can see three default output commands are used in gridmo's example model. These values are used to initialize other power system software, such as PSCAD, or help initialize PSS E dynamic models which do not initialize from a load flow result. We need to change the 999 bus reference to 500 like we did before. And as we have an on-load tap changer in our PSS E model, we should add a command to export the tap ratio. To do that, we'll click on the little help bubble to the top right of the text field, which opens gridmo's docs. We'll then scroll down on the right until we see output transformer value and click on it. We can now see the construction of the command, and we can copy the example down the bottom. We need to change the TX equals argument, set val to tap ratio, and give it a name. Let's call it I_TX_ratio. The I indicates it's an internode variable, that is a value which is exported from one power system simulation and input into another node, such as another power system simulation or an output like plot, table, or analyze. The output vdroop target command helps to convert a reactive power value at the connection point into a voltage droop reference. We're pretty early days for Sunny Solar Farm. We haven't completed the static studies yet to select the droop characteristics, so let's leave this as is. We've reached the halfway point of setting up our PSS E model. We've completed the file definitions and set all the static study variables. We'll continue in the next video with the PSS E dynamic model configuration.